Hi, my name is Luke Monington. In this video I'm going to be explaining the difference between label encoding and one hot encoding in 2 minutes flat without using code. Alright, so let's say you have this table and you want to feed it into an AI algorithm. In order to do that, you'll need to first change this column so that it has numbers instead of words. The reason you need to do that is because most AI algorithms only work with numbers, so if you gave it data that has words or letters, it would just throw an error. One way of changing the column so that it has numbers is a method called label encoding. This is a two-step process. The first step is to fit the data. What that means is to look at this column and to create a key where I assign a number for each category. The second step is to transform the data. What that means is to take this column and to take this key that I just created and use it to give numbers to each row. So for example, the first row is blue equals 1, so I'm going to put a 1 here. The second row is green is a 2, I'm going to put a 2 here. And you do that all the way down the column. One thing you'll have to consider is that giving a number to each category like this gives an order to the categories. That would make sense if there's actually an order to the categories, but with colors, there isn't an order. So this would actually confuse the algorithm into thinking that there was some type of order or hierarchy in that column when there actually isn't. You might be asking, what would be a good use of label encoding? Well, you'd want to use it whenever you have a column that has an order or hierarchy. For example, this column has a difficulty where it has easy, medium, and hard. Obviously, that has an order to it, so this would be a good use of label encoding. In that case, how would you encode a column like this that doesn't have an order? Well, you would use a method called one hot encoding. One hot encoding also has two steps. The first step is to fit the data. We will look at this column and we'll create a key, but this time instead of assigning a number for each category, we'll just keep track of each category. The second step is to transform the data. For one hot encoding, we'll create a separate column for each category. Each of these columns is a binary column, so it will either have a 1 for yes or a 0 for no. For example, for this first row, the color is blue, so we're going to put a 1 in the blue column and a 0 in the other two. The second row is green, so we're going to put a 1 in the green column and a 0 in the other two columns. This will be a much more accurate representation of the data since it does not imply that there is any order to it.